Hi, my name is Josh Dodge, and in this video, I'm going to be discussing an article that I recently got published with IABS Publishing, which stands for International Association of Business Scholars. The article, or the guest article that I got published, is the Numerical and Polynomial Synthetic Division with Negative Digits. And yes, it's a mouthful. So I'll be including a link to the article in the description, and also I'll include links or a link to the article in the presentation. So let's get started. In this particular video, I'm going to discuss an overview of the article, and I'm also going to show you a couple examples. The first example would be with polynomial synthetic division, and then numerical synthetic division. So this is an overview of the article. So I took two ideas. I took Vedic mathematics, and I took the extended form of synthetic division. With Vedic mathematics, specifically, I took Vedic division and negative digits based upon works that I saw with Arthur Benjamin, who did lectures on mental math, and he showed a particular method with Vedic division. And then also Sameta Bose in his work on Vedic mathematics, I took that as well. And then I saw similarities between that and the extended form of synthetic division. With the extended form of synthetic division, it was an article that I read years ago by Fan, and he discussed how you can divide any polynomial. The divisor does not have to be x minus c. It could be any polynomial, could be your divisor, and you can do that with synthetic division. So I took those two ideas, and that led me to numerical synthetic division. So first, let's look at an example of polynomial synthetic division. So if you recall, with synthetic division, you write the coefficients of the dividend, and then on the side you put the divisor. So let's do that. So 15, negative 27, negative 35, and then 60. Now on the side, you're going to put your divisor. Now I'm going to put negative 9, but we're not going to put negative 9. We're going to do the opposite, which is a positive 9. Because with division is repeated subtraction, so you do the opposite. Now I'm going to make it's going to look a little different compared to regular synthetic division. Now with the leading coefficient of the divisor, which is 5, we're going to write it as a reciprocal, 1/5. You could put divided by 5, but for consistency, I just make it multiplication. And so that's 9. I'm going to be multiplying, and then this is the reciprocal. Multiplying by the reciprocal is the same as dividing. Now, we're going to write in a remainder box, which is going to go here, but it's going to be the same length as the number of terms on the side. Here with a binomial, it's one less term, and that's the same with anything that you're dividing. It's always one less term, and it's going to be symmetrical, as you can see. All right, with synthetic division, the first thing that you do is just drop down that leading coefficient, which is 15, drop that down, and then divide or multiply 15 over 5, which is the same as 3. Next, you're going to put it in the next column. 9 times 3 is 27, always in the next column, and then add. Negative 27 plus 27 is 0. That's really convenient because 0 over 5 is just 0. And then 0 times 9, right, put that in the next column. Negative 35 plus 0 is negative 35. Negative 35 over 5 is negative 7. Negative 7 times 9 is negative 63, and that goes there. And then you're going to add 60 minus 63 is negative 3. Now, the way that you would write these, you can find how to write these based upon the leading coefficient. So you can do 15y cubed over 5y, and that's 3y squared. So this is 3y squared, and then it descends. So that would be 0y, and then the ones place, or y raised to 0 power. And then this is the remainder. So we can write it like this. 3y squared. We can skip the y because that's 0 minus 3. And then I can put the remainder over the divisor. So negative 3 over 5y minus 9. All right, now let's look at numerical synthetic division. Now, it's going to be to our advantage to use negative digits. So I'm going to take 349, and I'm going to convert that using negative digits. So 349, and that is the same as 350 negative 1. I'm basically getting rid of the 9 and substituting it for something that's easier. So you're going to do the same thing as before. We're going to list out those coefficients for the dividend. So 6, 4, 5, 3, 4. Now we're going to do the same with our divisor. So with our divisor, we have 350 negative 1. And by the way, that's a negative 1. So that is using negative digits. So negative digits is taking a negative 1 and you put a line over it for convenience, because it gets clumpy if you put with negative digits if you put the sign in front. So with negative digits, you just take the 1, you take whatever the digit is, and you put a negative sign over it. Now remember, the signs are the opposite, and it starts in descending order. So that would be a positive 1, that would be a negative 5, and then on the bottom, I could do divided by 3, or I can do multiplying by the reciprocal. I'm just going to, again, multiply by the reciprocal. Now let's put in our remainder box. Now the remainder box here, it's always one less term. So here it's 3 terms. So it would be 2 terms here, and notice it's the same 2 as on the side. All right, first bring down the 6. Then we're going to divide, or 6 over 3, which is 2. Now you're going to do it at a diagonal. You would have done this also for polynomial synthetic division if it was a trinomial. So you're going to do the same thing here. You're going to put it at a diagonal. So 2 times -5 is -10. And then 2 times 1 is 2. Then add the next column. So that'd be 4 minus 10, which is a -6. -6 over 3 is a -2. Now we're going to do the same thing again. -2 times -10 is +10. Again at the diagonal. And then 1 times -2 is -2. So you can kind of see that the pattern is, okay, bring it down, divide, then multiply at the diagonal, add the column. Once you add the column, you divide, then the diagonal. So the pattern just repeats. 5 plus 2 plus 10 is 17. We're going to divide that by 3. So when you divide it by 3, you're going to use, if it doesn't divide evenly, you're going to use short division. 3 goes into 17 5 times with a remainder of 2. And you put the 2 on top with the dividend. Remember, this is the dividend. So whenever you have a remainder, put it there. And this is the same thing that you would do with short division. All right, now we're going to multiply at the diagonal. So 5 times -5 would be -25. And then 5 times 1 would be 5. Now, once you get to the remainder box, you're done. You don't continue on dividing. So then add the columns. So that's 23, -27, so that's -4. And then 4 plus 5 is 9. So the answer is 200, -20, +5, with a remainder of -40, +9. Now that's not very pretty. So what you want to do is you want to convert it so it's not a mixture of both negative digits and positive digits. So this is 20 minus 2 tens. So you can just do 20 minus 2, which is 18. So that's 185 with a remainder of -40, +9. Now, with that remainder, it's a negative remainder. So you want to make it positive. And the way that you can make it positive is borrowing 1 whole. Now, when you borrow 1 whole is the same as your divisor. So if I'm borrowing 1 whole, then I would add 349, or if I want to make life easy on myself, I can add 350 -1. And that's what I'm going to do. 350 -1. So my remainder becomes 318. Now, since I'm borrowing a 1 from 185, that becomes 184. And that's it. So take a moment to check out that article. In the next weeks or months, I'll be making videos explaining more of the math from that article. And in the next video, we'll be looking at negative digits. So please like and subscribe and ring that bell to get those notifications. Thank you, and I hope you have a good night.